Drone crimes have become prevalent issues over the past few years. Drones may be used to transport contraband, such as weapons or illicit substances, and drones have been used in illegal surveillance instances. As heavy-duty drones become easily accessible to consumers, it is important for counter-drone measures to develop as well to mitigate these dangers. With an increasing number of drone sightings at airports and other restricted airspaces in recent years, a solution must be proposed. After much research and consideration, SCAMS developed an anti-drone turret to combat the use of drones for any illegal purposes in both restricted and militarized airspaces. Our overall goal for the project is to create a proof of concept for idea in order to explore and better tackle the nuisances and danger drones can pose. After multiple interviews with robotic experts and the Bloomfield Hills Police Department, we changed our design philosophy to be more safety-oriented in the real world. Additionally, after interviews with airport workers and research on current issues with drone sightings, we found that drones in airports need to be dealt with immediately. With the various uses for drones, one key concern expressed in our research and interviews with law enforcement was the importance of selective measures. This boiled down to drones potentially carrying packages and the threat such packages might pose from the air or the impact from hitting the ground after being shot down. In order to account for these nuances, we incorporated a human input into our system to assist the turret in shooting down drones which were deemed safe by an expert operator. Building this in allows more flexibility and increases the scenarios where a turret can be useful and effective. Humans are much more adept at considering external factors like public presence in an area or the possible contents of the package the CV model detects on the drone at this stage. Such considerations wouldn't be optimized or accurate enough for a CV model to make, which would possibly put lives at risk. In our simulation, we are accounting for three main possibilities. One is where the turret immediately shoots down a drone if no package is detected by the CV model. The second one is when an operator is prompted by the CV model if a package is detected in order to maintain safety. The operator can deem it safe to shoot down or not. If safe, the turret will then shoot, hopefully taking down the drone, or the drone might escape because of the time difference between the prompt and the response by an operator. This is SCAM's first anti-drone prototype. Now, our system begins with drone detection by our computer vision model. The CV will use the stereo cameras to detect a drone and approximate the distance. With accuracy of 90%, the drone will be the only thing targeted by our model. Animals and helicopters will remain safe. Then, information is sent to the Arduino to control and to reposition the turret to adequately aim at the drone. Once the computer vision model confirms the drone is accurately being aimed at and the turret is ready to fire, the Arduino will relay a signal to trigger the firing mechanism and shoot at the drone. It will shoot water to ensure no collateral damage on bystanders, but pressurized enough to hit a drone and take it out before it causes any more damage, nuisance, or poses any danger to anyone. Go. The project has reached a stage where prototypes with the computer vision model can identify drones at a distance with high accuracy, supported by realistic simulations for operator assistance. Future goals include enhancing the drone differentiation and expanding the simulation and improving the turret's targeting system, all aimed at making the airspace safer.